Okay, this is 14.1.5 applications. And we're going to talk about applications of matrices. And the first one we've already done, but I want to show you why this works. So we can write this system of equations. So solving systems is a great application of matrices. We can write this like this. Now, if I show matrix multiplication, I do row times column. That gives me 2x plus 3y equals 7. Well, that was my first equation right here. If I do the second row, row 2 times column 1, 3x times negative 1y equals negative 5. And yes, that's my second equation. Now, reduced row echelon form works for one reason that I've shown in pre-calc. But functionally, what it ends up with is this, and some answer. And that's 1x times 0 plus 0y and 1 or 0x plus 1y equals whatever's over here. So that works in one way. The other way is this, which I can call this A. I can call this the XY matrix that I'm multiplying by, and this is my answer matrix we'll call B. Well, if I want just to solve for XY, I need this A to move. And the way to do that is to multiply by A inverse. The key, though, is that I write multiply by A inverse. So I have A inverse A, not A XY A inverse, because matrix multiplication, remember, is not commutative. So I have to left multiply. And what I've been having you do is you enter the matrix, you do its inverse times the solutions, which is B, and that gives us XY. Okay? That is why matrix multiplication on a calculator works. That is the easiest application. These applications actually aren't that bad. And we're going to do all the multiplication on the calculator. So yes, this is them showing that. Example 2 does it with 3 variables. We've already done 3 variable systems, I think, with matrices. But we write this out. Here, I'll show it written out here. Write it like this. This inverse times the solutions equals XYZ. And yes, I believe you've done that. We are not finding that inverse by hand. I don't even need you to write it out. You're just going to use the calculator. Enter it in, hit times here, get your solutions. Okay. So now we're going to talk about using a thing or a chart and making matrices to solve. So it says the members of the chess club are ranked based on points awarded for winning games in various competitions. The table shows the number for each competition won and the total number of points for the top 3 members of the club. Find the number of points. So this would be like saying in equations, this person has 27 wins in practice matches. 27 times X is going to be the number of points for practice matches. Plus 9 wins in the city tournament, 9Y is points for city tournament wins. 8Y, 5Y. Regional tournament wins. Oops, not Y again. Z. So now I just have a system of equations that I can put into matrices. And to solve for XYZ, I just do 27, 9, 2, 24, 8, 1, 35, 5, 1, inverse times 289 218, 195. So I'm going to go over and put that into the calculator. Three by three. It's a little bit written over, but I'll clear it once I get down. To do the inverse, I do to the power of the little caret. Move that out of the way for a second. Caret. Yep, there we go. -1 times columns is going to be 1. 289, 218, 195. I'm going to clear everything out of the way here. Okay. I hit enter. So that looks like 2 points for practice wins, 15 points for city tournament wins, and 50 points for regional tournament wins. So X was 2, Y was 15, and Z was 50. And so we just took a table of things, put it into equations, used a matrix, and solved it. Here we can do it with 4. Same thing, except essentially I might just use A, B, C, D. And I can put them all into matrices. And I can solve the system of matrices. The participant did 4 kinds of energy bars they can eat. Number of bars consumed by each participant and the total number of calories are noted. Okay. And again, I can do as many variables as I want as long as I have that many equations. Or in this case, I can do as many bars as I want and total calories as long as I have that many participants. And so there's your matrix. Right down here, A, B, C. To solve, we do A inverse C. 180 calories for bar A, which was peanut. 100 for vanilla. 180 for cherry. And 150 for apricot is what it looks like. Okay, matrices can also be used to encrypt. So here we've got this nice little encryption table. And this is using the whole alphabet in lowercase and numbers 0 through 36. And so we're going to encrypt this. This is a pretty simple encryption formula, but we're going to encrypt that. So the first letter is M, which has a 13, so I get a 13. Second letter is Y, so I get a 25. Third letter is P, so 16 for P. 1, 27 for 1, 28 for 2. So that is 12 letters. They intentionally did 12. I think if we came up short, we'd use zeros. They don't have a great example of that, but I think we just use zeros because we're now gonna put it into a matrix. Okay. And whatever we're going to use for an encryption matrix is going to have to match in dimensions, kind of. So they've chosen a 3 by 3 encryption matrix. The key for the encryption matrix is that it is square. So if we're using a 3 by 3 encryption matrix, we know that if we're going to multiply it by my phrase, I have to have a 3 by something. Well, for 12, that's got to be 3 by 4. If you used it, you could use a 2 by 2 and have 2 by 6 matrix, but remember when we do matrix multiplication, this has to line up. So here we get our string, my password 1, 2, being translated like this. 1 here, 19 goes to the next row, etc. 28 here at the end. And again, I think you would just use zeros if you didn't have something. This is my encryption matrix. Notice that my encryption matrix to match up here has to be left multiplied. E must be on the left, so 3 by 3. So I'm not going 3 by 4 times 3 by 3. That doesn't work. The inside dimensions have to match. So we're going to encrypt, so we just multiply this. And yes, you could stick it into the calculator and you would get that. There's my encoded matrix. That's what I'm going to pass along. This was a very simple encryption key, but you have to know this E. Even if you know the encoding table, not knowing the E matrix won't be helpful. So right now here I've got EP is my M matrix. That's what I'm sending. That's what I'm going to send and pass along, and nobody's going to know what my message is. Well, to get it back, I just have to multiply by an inverse. E inverse. And again, this must be left multiplied, so it's E inverse E P, because E inverse E I can change to the identity. So I have to do E inverse M, which again, that should work because E inverse is going to be 3 by 3. And I'm going to multiply that by M was a 3 by 4. Okay? And you are not going to get these inverses by hand. You're going to do this on the calculator. So E inverse. I'm going to write down E. I'm going to write down M. And we'll check that we get the results. Just need to write it on a separate sheet of paper here so that I can compare. Enter them into the calculator. 2. The first thing I'm going to do is get matrix E in here. And I'm going to just get its inverse and store it. Actually, -2. Oops. I'll probably just store this as E right away. So if I'm doing quite a bit of encryption, I'm just going to store. I'm going to do matrix M now. I do need to get it to 3, 4 columns. So if I want to decrypt, I can do E. Put that up there then. To the power of -1 will be an inverse still. E inverse M. And that is my original matrix. Okay? That one they kind of walked you through. This next one, we're going to encode HL Math 1. So, and they gave us a new matrix E. So HL Math 1, this is a 2 by 2, so I need a 2 by something. I think it's going to have to be 1, 2, 3, 4, 5, 6, 7. So I will make my matrix P. H is an 8, L is a 12, M is a 13, A is 1, T is 20, H is 8, 1 is 27. I'm going to make my last one 0. I'm going to double check that that's what they want me to do with the last one. Oh, nope. They're making space 37. Okay. They want space to be 37 in this one. I missed that in the. This is going to be 37. So it simply wants me to do the encoding matrix. And so I'm going to write down my matrices and we're going to go to the calculator. 2, 1, -3, 7. It is E, and P is 8, 12, 13, 1, 20, 8, 27, 37. I go over to my TI Inspire and I go, okay, matrix 2 by 2. Since I got a 2 by 2, I'm just going to use the shortcut. 1, -3, 7. I'm just going to store it as E so I can do E inverse. That's my new E. This time it's a 2 by 4, so I have to do both of those. 8, 12, 13, 1, 28, 27, 37. I'm going to start as M. So now my encoded matrix is just E times M. Oh, I should have started. This should have been P. Oops. Now let's store this as N for the sake. So that's my solution matrix, my M. I encoded this wrong. So I just did copy and paste. So this should be stored as P. So E times P, that's my encoded matrix. Same thing I got before, but now I need to store it as M. So now E inverse times m will take me back to the original. I'm going to take the original here. I want to see what's going to happen if I use a 0 instead of a 37. No, I don't want that as m. I need to start as p. Oh, wait. Just for kicks and giggles. So all I'm doing is switching the 0 to a p to see if it matters. Because I don't know if it will or not. Now we're going to try E inverse times that matrix. No, it doesn't matter what I call the blank space. I can call it anything I want. So when you're encrypting, it is totally fine to use whatever you want. If your characters aren't as long as you think, you just fill it in with zeros or a space character. Okay. So we simply put our encryption matrix E, we multiply it by our message P matrix. It's important, though, in recap, that the dimensions, and I'm going to go back to the book for a second, that the dimensions of E here and P here, that it's 2 by 2 for E. So whatever that is, P has to be made that this here will match. Okay. We always left multiply by the encryption matrix. And then when we want to undo, we left multiply by the inverse. Okay. So we're always going to be left multiplying. Otherwise, the dimensions don't work. Okay. That is 1.14.5. 1.14.5 applications of matrices.